In this example, we're given a function that models the number of snowboarders we have in millions, depending on the years t since 1990. And so go ahead and if you need to pause the video to get this big long equation typed in, double check and make sure you've typed it in correctly too. It's easy to mess this up and that screws up the whole problem. So I've typed mine in already. And while you're, if you didn't pause the video while you're typing it in, just a couple things to note up here. Note that this equation only works between the years 1990 and 2000. And so I made a little note that that really tells me what my domain is for this problem and my window, my x min and x max. I'm going to go from 0, which represents 1990, because remember it's years since 1990, and 10, which would represent the year 2000. So let's go ahead and set up our window, because if you hit graph right now, you're not going to see much of anything that you want to see. So let's adjust our window first to begin working on this problem. As I just said, the x min, x max, let's adjust those to 0, which represents 1990, and 10, which represents 2000. And it says that's the only part that this equation makes sense for. It doesn't make sense to go to 2001. It's only between these years. Our y value then, our output, s in the function, tells us the participants in millions for people who were snowboarding. So as a minimum, let's say 0, because maybe 0 people were doing it. And then as a y max, I don't really know, but I just need to make a reasonable guess. And when I did this, I guessed 2, which would stand for 2 million. And it turned out to work out just fine. If you didn't see enough or saw too much, we could adjust that number and play around with it. But 2 ends up working out just fine for this case. And again, it was just a total guess that 2 works. So if you hit graph, you can kind of see this function. So we've got people, more people are snowboarding, and then we kind of hit a maximum. They drop back off, and it looks like we get a few more people snowboarding there at the end of that decade. So let's answer a few questions about this. First question is, how many people participated in 1995? Well, I made a note that that means that t is 5. And so there's a couple ways you can do it. What a lot of people do is go to their table, which would be just fine. So go to your table. Oops, my table, forgot to check that. My table started way high. Let me just change this real quick. Your table probably started from 0. If I start from there, then I could look up just 5 in my table, and right there would represent my output, 1.6725, remember, million participants. So that's one way that works out just fine to do it. Another way is from your graph, hit the trace key, and if you hit left or right, you can trace out different x values, and I was lucky enough that x ended up on 5. And there's my 1.6725 million. But suppose it didn't. Suppose they wanted 4 to represent 1994. If I scroll, I don't get to 4 exactly, but here's a cool little trick. Just type in 4, or whatever x value you're trying to find, and hit enter, and it'll jump right there for you. So in 1994, there are about 1.68 million participants. All right. Next question is a little bit different. This time they ask me, when did I first get to 1.5 million participants? The reason this question is different is they've now given me a y value and asked me to go backwards and find the x. So again, I could look at my table. This time I'd be looking in the y column for 1.5, and I can see that it must occur somewhere in here between 2 and 3, which is 1992, 1993, but I can't be any more accurate than that with my table. So what I like to do is this trick. Go back to y equals, and anytime they ask you for a y value, type that in as a second equation, so type in 1.5. Now the line y equals 1.5 is going to be a flat horizontal line, and we can see that there are 3 times in this decade where there are 1.5 million participants. I want to find this first intersection point. And so to do this more accurately than using your table is to hit second trace, and then select option 5, intersect. And all you'll need to do is trace your cursor, use the left and right arrows, trace your cursor so it's somewhere close to that intersection point, and just go ahead. They're going to ask you 3 questions, but really you can just press enter 3 times to do this. So first curve, press enter, second curve, press enter, guess, press enter, and what it'll do is it'll find me the exact intersection point when x is about 2.2. Now remember, that represents 2 years after 1990, so that's why I gave an answer of about 1992, a couple months after 1992, I suppose. And then lastly, they ask, or actually I have one more question after this, so second to lastly, they ask me how many participants would there be in the year 2020? Well, like we did last time, we could check this, or like we did the first time, we could check this in our table. In 2020, that's 30 years after 1990, so you have to scroll way down to when x is 30. And as you're doing that, you'll probably start to notice that your y values are getting really, really big. And so the question was, is your answer reasonable? And of course now it's freaking out on me and not getting there. Come on. Well, I trust that you can get down to 30. But the question, or what ends up happening, is I end up with 563 million participants, and so there's no way that that answer is reasonable. That's over the population of the United States that's becoming snowboarders in 2020. And the reason why this isn't reasonable is, remember, my domain was only between the years 1990 and 2000. So going all the way to 2020 doesn't make sense. It's outside the domain.